Welcome. God, a good crowd tonight. What are we talking about tonight? Everybody's kind of interested in this one, I guess. Anyway, well, it's really great to have you here. If you haven't been to a SOGIS panel, we do 3 of these a semester, I think, 2 or 3, right? A semester, depending on the 3. We have another one coming up. Yeah, okay. Anyway, and they're really kind of informal. So we bring a group of experts from the community and from the campus to talk about a topic of interest. And tonight we're going to be talking about low snow, high stakes. So there's a lot involved in that. So I hope it'll be a great conversation. Just some announcements on February 17th at 6 p.m. At the Fort Collins Old Town Square Visit Center. The Africa Center will present Richard and Catherine Frazier presenting their experiences as educators and volunteers in the Peace Corps from their work in Africa. On February 23rd, we'll have a virtual colloquium from the Office of International Programs and the University of Yucatan. Both institutions are working with regards to clean energy and clean energy science, so that'll be interesting as well. So if you're interested and you're not a member, you can sign up for the SOGIS emails and also at the website, sustainability.colostate.edu. So you can get on the site there. It has all the events. It has SOGIS events, but also other campus events as well for the Climate Center and all of those. And people that are standing, if you want to grab a chair, you can just pull them in over here. There's chairs right outside this door. And so normally I provide chairs for everybody, but I've got to do this. So anyway. The way this works is we'll introduce the panelists. They'll give us a brief summary of the work they're doing currently, and then we'll open it up for questions from the audience. We ask that you raise your hand, of course, and stand when you ask your question. You need to give a name, give somebody else's name if you want, and you get to plug something. So if you have something you want to plug, like a business or something like that, or a club, you can get a few minutes. We'll take 30 seconds, okay, to do that. A few minutes, get people staying here all night. I'll introduce the panelists and then we'll have them talk a little bit about their work. Jude Bayham is associate professor in the Department of Ag and Resource Economics, an economist with research interests at the intersection of public policy, human health, and natural resources in the environment. Jude also works on the economics of outdoor recreation and the impacts it has on local economies. Welcome aboard. And you're all first-time panelists, right? This is great. This will be fun. Yeah. Allie is an engagement climatologist with the Colorado Climate Center. In her role, she helps provide climate services and outreach throughout Colorado. Her research interests include high-impact weather forecasting, interactions between weather and society. So we'll hear about high-impact weather. I'd like to hear what that is. McGrath, colleague of mine over in the Department of Geosciences, specializing in glacial dynamics, seasonal snow hydrology, and climate change impacts. His research uncovers how glaciers respond to climate shifts and the implications for water resources. So pretty rich topic tonight. And usually we'll open it up with the audience asking the first question. So anybody want to start with a question tonight? There's always somebody. I can always count on Dennis and Jill, but then, oh, there they are. Okay, anyway. Any question? Because you don't want me asking questions all night. So come on, there we go, Jill. Sam knew it. There we go. Okay. Oh, come on.
Dan wanted to talk a little bit about what they're doing right now.
Jill, you've been here more than me. I'm sorry. I forgot. Anyway, Jill, you want to take over, Jill? I totally spaced that out. It's like the time, I'll tell you, self-disclosure, one time I came here for a panel about 10 years ago, and I may have stopped at the mayor to have a beer or two before I came over, and I forgot to introduce Governor Ritter. The Governor Ritter was sitting up there and I go, Governor Ritter, what? Oh my God, I forgot to introduce you. So anyway, well, let's start with you. Give us a bit about what you're working on.
All right, can you all hear me?
Yeah.
All right. So thanks for the introduction. I think you touched on the high level. I like to think about how people respond to risk, and I think about that in the context of like natural disasters are sort of climate stressors. So wildfire management, flooding, more recently. And I've been working a bit on outdoor recreation, how those things interface with outdoor recreation. I think most relevant to this panel, I have a paper I've been working on for a bit on how skiers, people that go to ski resorts, respond to snow depth and snowfall. There's a few other papers in economics on this, but we take it a step further and say, how do those changes then cascade into the communities, the local communities in that area. And I think one of the headline results that we're trying to sell is those effects are really acute, really close to the ski resort. So if you have a restaurant or something like that near a resort, then you're really dependent on people going skiing, right? And therefore you're dependent on the snow depth and snowfall. And then that tapers off as you get further and further away. So maybe like 30 kilometers or so, which is what, like 17 miles maybe, that effect starts to fade, at least around our western ski resorts. So I'll leave it at that.
Great, Allie.
Hi everyone, I'm excited to be here. So I work as a climatologist in the Colorado Climate Center. We're in the Department of Atmospheric Science here at CSU. So in my role as an engagement climatologist, I do sort of a combination between education and outreach, providing climate information and climate data to folks throughout Colorado, as well as some climate research as well. On the research side of things, I guess what I'm working on right now is a few people from our team are helping out with a project with some other folks from the Department of Atmospheric Science for providing data and analysis for a report for the Colorado Governor's Office on their publishing a report on climate. They call it, I think, their climate roadmap. They're publishing an updated version of that later this year. So we're kind of doing some analysis on how hail might change in a future climate, how drought might change, sort of drought indicators, snowpack. We're working with both folks from CSU as well as the University of Wyoming. So that's been a really cool hands-on research project that we've been doing. But I think the bulk of my time, honestly, right now has been taken up by snow and drought. We've gotten a lot of questions in our office about the snowpack situation. I'm sure all of you folks are here. You know that it's not great. So happy to chat more about that throughout this panel.
Okay, great, Dan.
Good evening, everyone, and thanks for coming out. It's great to see so many folks here. Excited to learn about the state of the snowpack and how we measure and all of its downstream impacts. So I'm an associate professor in the Department of Geosciences, and broadly speaking, I'm a cryospheric scientist. So I study basically all the frozen parts of the planet. That may be, Antarctica, Greenland, glaciers in Alaska, or the seasonal snow in our backyard. And so I have research projects, primarily up in Alaska and Patagonia, and then here in Colorado at present. And really interested in understanding how glaciers are changing, what that means for water resources. And a lot of my work recently has been focused on how do we measure the snowpack, right? We'll talk about snow stations today. We'll talk about snow surveys. But those are generally point observations. And right, the landscape here in Colorado and across the West is quite vast. And even though we may have 1,000 snowtail sites, that's a really small set of observations to understand what the snowpack looks like. And so a lot of my work has been focused on using satellites to measure the snowpack, using a radar-based approach. And so I'll touch upon kind of the future of this snow remote sensing and how we might get a better picture about the state of the snowpack down the road.
Okay, great. Thank you very much. That really helps a lot. Anyway, so who wants to have the first question? Jill? No, I'm just kidding. We have an answer. Stannis. During this, the variability in snowfall and the intermediate warming periods, can you say something about the increased avalanche risk because of snow conditions, and how do we communicate that to the communities in the mountain areas about the increased, potentially increased risk, or what's your thoughts about the increased risk around avalanche danger? All right, grab that one, somebody.
Great question and a complicated one, right? I mean, there's, to have an avalanche, you have to have the massive snow on the slope, and you need to have a bed surface for that, weak layer for that avalanche to initiate on. If you did have variations in temperature where you could get, say, a sun crust covering a large amount of your current snow surface, and then you get a subsequent large magnitude snow event after that, that would make it more prone, right? You have this weak layer for which that new snow is not going to bond well. I haven't seen a lot of reports of increased avalanche activity this year here in Colorado. I don't know if my fellow panelists know more about that. You know, if we look to the future, like climate projections out, 50, 70 years, that is something that folks are trying to answer that question of like, what is that snowpack variability going to look like? What are the magnitude of those individual storm events? And how might that temperature fluctuate between those where you get increasingly those kind of mid-pack weak layers? Here in Colorado, we really deal with depth core at the base of the snowpack. And that's a really common problem because we generally have a relatively shallow snowpack compared to the maritime environment. Like you go to the Sierra Nevada, you might have 6, 9 feet of snow versus here in Colorado, if it came and passed, we're lucky if we have maybe 6 feet in a really good year. This year, we're looking at like there's about 3 feet up there. That's a much smaller snowpack. And what that means is the temperature gradient between the ground, which is always right around freezing, and the atmosphere is much steeper in a continental climate, like what we see here in Colorado. That steeper temperature gradient drives metamorphism of those ice crystals. The snowpack is constantly evolving, constantly like responding to those changes in temperature. And so because we have that really steep gradient, we tend to get these really weak layers at the bed of our snowpack. And a lot of our avalanches are full thickness avalanches that go to the bed because of that weak layer there. But I've not seen, even though we have a really shallow snowpack this year, I've not seen reports of increased avalanche activity. And you know why? Probably not that many backcountry skiers out there, right? The trigger in many cases is greatly reduced in this case because there's many fewer backcountry skiers out there.
Any questions? Let's go. Here we go. See what gets you next.
Hi, I'm Haley. I have a question about dust on snow. I've heard a lot about this in like southern New Mexico northern New Mexico, southern Colorado, like not as much here, and maybe it's not all in those circles here. But specifically, I want to understand, like with dust on snow, is that primarily an effect of like dust coming in from all over the world, or is it our problem, like in the US Southwest? Like, are we losing soil stabilization due to like low veg cover? And depending on what the effect is, or what the impetus of the effect is, like what are the strategies to mitigate it?
Okay, dust on snow first.
Dust on snow.
Go ahead.
Okay, dust on snow. We primarily think about that in a snow hydrology perspective from kind of what is the reflectivity of the snowpack surface, right? So if you get dust on snow, you're changing what's a highly reflective surface to a much darker surface that absorbs a lot more of the sun's radiation and therefore melts much faster. And so when we have had very large dust on snow events here in Colorado, which is generally much more prevalent in the Southwest, so the San Juans are the most prone to these dust on snow events, it can melt out the snowpack up to 30 days earlier than in the absence of that dust on snow. I think it's more of our problem. It's a kind of desert Southwest origin for a lot of the dust events. And you can see it. There's some spectacular animations out there using the GOES satellite, which is these geostationary satellites. So they're at 36,000 kilometers above the Earth's surface, but they're taking images every 15 minutes. And you can watch these kind of cold fronts come racing across the West, and you can actually see the dust plume out in front of them. And you can watch that track up into Colorado. And I don't know if the Climate Office has those, but you can Google around, and so you can watch basically the track of these storms as they come and carrying that dust with it. That is generally what is referred to as wet deposition. I think when it's actively precipitating, the dust comes out with it, and that's a wet deposition, versus you can also get dry deposition, which is in the absence of that precipitation. So really from the hydrology perspective, it just lowers the reflectivity and causes faster melt rates and earlier melt out. And I'll just keep like 1 second segue, because that's kind of what was happening in our backyard, not from dust on snow, but from post-wildfire impacts. So I've spent a lot of time up at Cameron Pass over the last 5 years on initially a National Science Foundation funded project, and now a Bureau of Reclamation funded project to understand what these post-wildfire impacts look like. And right, if you've been up to Cameron Pass or in the East Troublesome Fire, these two huge fires, the two largest fires in Colorado history, those trees are shedding soot onto the snowpack, and it is highly absorptive of sun's radiation. And I have some photos from that first winter post-fire that spring. there's just layer upon layer of soot in that snowpack, and it melts so much faster. You're going from a albedo, which is a technical term for the reflectivity, from something like maybe 0.7, which is just a ratio of how much is coming in versus how much is being reflected, the other way around, but down to like 0.4, 0.3. So you're just absorbing 30-40% more of that energy that's coming onto that snowpack. And so that just warms it up and melts it faster. And so we're seeing that here in our backyard, and we're seeing that across the West. Something like 13% of the Western US is within a wildfire burn scar. And increasingly, those fires are happening at higher and higher elevations where we accumulate these really deep, persistent snowpacks. So it's a really critical issue. And the Bureau is very interested in it because, right, we can talk about the natural reservoir, but if that reservoir drains faster, and the reservoir I'm referring to is a snowpack, if it drains faster earlier in the spring, your human-made reservoir has to be able to account for that. And at present, they are not prepared for that.
Great. Okay. And there's some studies at CSU that dust in the San Juans is usually coming from the basin and range area. So regional sources, and then the West Coast is like Gobi Desert in Asia and stuff. So anyway, okay, next question.
Well, the other question is what we can do about it. And basically, vegetation cover. Wind erosion is very, very sensitive to relatively low amounts of vegetation cover. Surface erosion, water erosion, you have to have much more bare soil to get high levels of surface erosion. But for wind erosion, you don't need very much vegetation to start making a huge difference in the amount of that wind erosion. Is kind of my basic understanding.
He knows.
He knows.
Yeah. Question over here.
This question is to Professor Bayham specifically because it relates to outdoor recreation economics. So like with this year in the news, Vail has been pretty prominent because there's been a pretty big decrease in tourism in Vail specifically, and you're seeing these innovative ways to get people in, like they did a concert up at the ski lift because there's no snow. So it's like, okay, let's do this pop-up concert. So at what point are you trying to bring tourism in to make sure the community is still getting the economic prosperity from tourism? But then if we have prolonged drought, at what point is that trade-off? Like, okay, well, we don't have the resources like the water to sustain tourism long-term. So how do you, long-term, how do communities combat that?
Well, thank you. That's a great and really complex question. I certainly don't know the answer. I don't have like not 45 or something. But I think you're hitting at the trade-off, right? So it's a trade-off between wanting to promote tourism, which a community like Vail is built around. So they need that to sustain their sort of economic viability. But then, the downsides, intuitively happen when there's too much congestion, right? Like too many people. So those two things probably don't happen at the same time, right? So they would react by trying to encourage people to come when they're on the low end of tourism, right? Now, often we see the flip side, right? We see many of our mountain communities get overwhelmed and they're dealing with congestion. So that's not the case right now. But I think you characterized it correctly that there's this trade-off, right? And so I think they're always trying to find that balance, and climate stressors on both sides, right? So whether it be low snow in the winter or high temperatures in the summer, or fire risk or whatever it is, make it hard to find that balance, right? Yeah. So I'll leave it at that for now.
Question over here.
Thanks. I have a pretty straightforward question, but I'll elaborate. The straightforward question is, Mark, why don't we have any snow this year? And like just to elaborate, like I watched a video recently about it that tried to explain it vaguely as there's a high pressure system that has persisted somewhere in the southwest, and it's kept like polar air from descending down into our area. But then I'm also curious about is what we're seeing like this year gonna happen again, maybe more severe or more frequently in the coming decades because of climate change, acidification trends?
Yeah, thank you for that question. We've gotten that question a lot. Yeah, you kind of, yeah, started in the right direction where when we look at our atmosphere, we're looking way up high in the atmosphere and we're looking at, we call them sort of wave patterns in the atmosphere. And when we get sort of these trough patterns that can bring down cold air from the polar regions versus ridging patterns can tend to bring up warmer air from the tropics. So yeah, this year in Colorado, we've been sitting under what we call a persistent ridge of high pressure where we've had sort of this dome sitting over us where all of the storm systems that have come down from Alaska or Canada have passed us either to the north or to the east. The East Coast has had a lot of winter weather if you've have folks you know out there. So yeah, that's sort of, we've been stuck in sort of this persistent weather pattern. We have also been in a La Nina pattern this winter. La Nina is a part of El Nino Southern Oscillation. Typically in Colorado, we don't have as strong connections to our precipitation as other regions do to La Nina and El Nino. But there is some evidence that our office has found that suggests that actually in the wintertime, parts of our state should expect wetter than normal conditions during La Nina. We obviously have not seen that this year, so it's not a foolproof direct correlation. Almost in every other scenario, we prefer El Nino conditions. So obviously that's not what we're seeing this winter. We are shifting towards neutral ENSO conditions. So there's not a huge tie between precipitation and a neutral ENSO setup. So we'll kind of see what the rest of spring has in store. Yeah, so kind of a combination of La Nina isn't necessarily the greatest for precipitation in our part of the state, in our part of the country. And also just we've been stuck in this constant weather pattern that hasn't allowed any moisture to really come in and bring us those big snowstorms.
Okay, go ahead, Dan.
Yeah, I'll just add one thing to that. I'm really glad we have an atmospheric scientist on the panel. So thank you, Allie. That's great. I don't like questions about ENSO because I just start waving my arms and don't really have a good answer. Just building on that response though, right? If you look at a map, who's been on the NRCS SNOTEL interactive map? How many, just show of hands, who's seen that where you have like all these dots, right? A lot of them look red right now when you look at this suite, the snow water equivalent. How many of you have ever switched that to precipitation and looked at that map? One. Have you done it recently? Cool. What's it look like? Good, right? It's good in spots. Like that's the kind of remarkable thing. So we have a snow drought across the West, and that's like kind of unprecedented, the spatial extent of a snow drought. But snow droughts can have many different flavors. And this drought that we're having here in Colorado is definitely a dry snow drought where we're at like 70% of the precip for the year and about 50% of the snowpack for the year. But if you look to the Pacific Northwest, who remembers the atmospheric rivers in December and the flooding? I mean, there are horrendous news stories of just catastrophic flooding. They are not having a dry snow drought. They're having a wet, warm snow drought. So basically what's happening is that precipitation is falling as rain and not snow. And so if you look at these maps, and I printed them out, I'll pass them around at some point. I just have 2 copies, so you'll have to pass quickly. But right, the whole West looks red in the snow map, but the precipitation map looks a lot more interesting and really points to the nature of the drivers of what we're seeing. Where here it's a lack of precipitation, elsewhere it's a warming temperature impact. And just anecdotally, I was talking with a friend and colleague who's a ski patroller in Jackson Hole Mountain Resort in Wyoming. And the valley floor was bone dry. There wasn't a snowflake in the valley floor in December and January. The top of the mountain, 4th deepest snowpack on record since Jackson Hole Mountain Resort had been operating. So we have these massive gradients where low elevation spots, it all fell as rain. Rain in December. The top of the mountain at 11,000 feet or something like that was getting a lot of snow. And I think this is playing out in a lot of places where the highest elevations are seeing a fair bit of snow in the Pacific Northwest into Montana and Idaho. That's not the case here. Across all elevations, we just don't have snow.
Right. Great. Question.
Good evening. My name is Dawson Metcalf. I work with the Conservation Leadership Graduate Program at CSU. My question is really tied to, we're in the midst of negotiations around the Colorado Water Compact. And I'm really curious if any of your work or research or anything that you're doing right now is intersecting with that to help inform, those negotiations. And if not, I would also be curious of like what you're hoping to see as a part of those negotiations, because I totally understand less snowpack, less water, and it's the cyclical cycle we're dealing with. So we'll just be curious from your perspectives on that.
I am not.
I don't have much. This is a really hard question, a really important question. I don't work in that space, so I don't have a lot to say here, other than I checked the levels of Lake Mead and Lake Powell, and it's pretty alarming how low they are. It's about 26 and 34% of their capacity right now. So, right, we're working through a drought here, a multi-year drought where these systems are being depleted. And you look at a year like this year and what that means for replenishment, and it's quite concerning. I can't really speak to the actual nature of the compact in those discussions, though.
Okay, question here.
I guess just one thing that
Sorry.
I'll just add really quick. I've been to a few different water meetings. Again, this is not exactly my area of expertise, but just sort of adding that there's certainly not a straightforward answer, and that the water community is very, very divided about it. So I think somebody will not end up happy with however it ends up.
But isn't one of the stories that the assumptions that were made when they created the first pact were based on a very limited number of years of precipitation? So, and they came up with that number 13 million cubic feet, and it was somewhere closer to 9 or 10 or something like that, right?
Yeah,
So
it was a good water year when they were making those allocations.
Yeah.
And also, I think that there was also some lack of trust in scientists, which we're seeing now.
Right.
So.
Daniel, come.
Yeah, just one additional comment here. We've primarily been talking about this year and the snowpack, right? The climate is warming, the anthropogenic climate change is impacting our snowpack. We've seen anywhere from about 15 to 30% reduction in the amount of snowpack that's stored on April 1st since mid-1950 or something like that. So we're seeing this like multi-decadal drawdown of this annual snowpack that accumulates there. That reduction that we're seeing, just that 15 to 30%, is equivalent to 25 to 50 cubic kilometers of water. And that is the equivalent of Lake Mead. So basically, climate change has caused our snowpack to decline by that much. What is stored?
Question.
Hi, my name is Mike. Just curious how abnormal this season is with snowpack, with moisture, with our historical records that we have, and then the long-term history, and then what our future looks like and the trends that we're looking at. And Allie, also, how big is the bubble that we're in? Like how far spread is it? Is it around the northern hemisphere? Is it just our area?
Yeah, I can answer that part really quickly. So Dan kind of alluded to that the Western US has gotten a lot of moisture thanks to atmospheric rivers earlier this year. So parts of the West have actually gotten some precipitation over this time. Really kind of the spots that we've been seeing drought conditions sort of increase the most are Colorado and Wyoming. Those two areas are sort of the places that we've seen the worst conditions. And then, yeah, Dan is the expert on our snow records, but you've probably seen a lot of news headlines that have been reacting on this being the lowest snowpack in history. And most of those are looking at the SNOTEL records, so our automated stations that we have throughout the higher elevations of Colorado. And those stations did not start to be installed until the early 1980s. So it's missing out on two of the really low snowpack years that we've had, which were 76, 77, and 80, 81. Those numbers that you see do not account for those two very low snow years. In the record that they do have, which is about 40 years or so, that's the kind of the record lows that you've probably seen a lot of headlines about. But yeah, Dan can probably speak more to the snow course data, which has a much longer period of record, but also has some strengths and weaknesses as well.
That's great. You covered a lot of ground there. Yeah, so really the snowfall record, which is our most spatially extensive set of observations right now here in the Western US, that references like 850 stations operating, 5,900. We have about 110, I think, here in Colorado. Sorry, I meant to say, keep those two together. They're a lot more impressive when you look at the red and blue back, right? I just gave one snow and one water over there and one snow and one precip over here. Try to keep them together. The flipping back and forth is really where you're going to see that impact. Sorry, I should have said that. But yeah, so the snowdell sites are a relatively new development, right? 1980s, our Cameron Pass site was installed in 1978. It didn't actually get a snow pillow until I think 1987. I looked at the earliest record there. So it's a relatively short time period, right? Roughly 40 years. The snow course surveys have gone back to the 1930s. There's this instrument called the Federal Sampler, which is just a really fancy tube, is all it really is, that you kind of insert into the snow and you bring up a core of that snow and you weigh that core of snow and you know the volume that's there and you know the mass when you weigh it, and it gives you the density and the water equivalent, right? Because we generally talk about the water equivalent, which is the amount of water that's being stored in that snowpack. Because, right, you could have a snowpack here in Colorado that's 2 meters or 6 feet, let's just say 6 feet thick in the spring, but if it has a density of 250, I'm sorry for using metric units here, it's just what's in my brain, so you'll have to bear with me, 250 kilograms per cubic meter versus 500 kilograms per cubic meter. That's going to significantly impact how much water you have there, either 1.5 feet of water or 3 feet of water, working off this kind of 6 feet of water. That density varies a lot spatially. If you go to the Sierra Nevada or the Cascades, that density tends to be a lot higher. So for a given snowpack depth in different locations, you have a very different amount of water stored in that snowpack. And I'm guessing there are many skiers in this room, right? You know how nice low density snow is to ski in. That snowpack, as it accumulates through the winter and into the spring, it's densifying. So the snowpack in May at the Cameron Pass is much more dense. You know, it might have a density of around 500 kilograms per cubic meter, which basically is saying that if you had 6 feet of snow there, you'd have 3 feet of water. It's a density of 0.5 or ratio relative to that of water. So it's really important to be talking about snow water equivalent rather than just snow depth, because it's really the water that's stored in the snowpack that we care the most about. And so, yeah, those coming back to these observations, the SWE surveys that were done by the snow course samples or surveyors, those started in the 1930s. And in 1976 and 1977, that winter in 1980, 1981 really stick out as low snow years. I was looking at that and the map of that spatially. Typically this year's usually like second, third. At Berthoud Pass, it was the 12th lowest year according to those measurements. So we're as low as it can go, unfortunately, in the historical record. But in many places, it is closer to like the second or even the first, the lowest snowpack since the 1930s when those measurements started. So we're really in kind of unprecedented territory. And I'll just say one more thing here is that I think the question kind of alluded to this, like, what does the future hold? The future is not very bright if you like to play in the snow. Like, I hate to be the bearer of bad news. I think you probably know this, but we're looking at anywhere from a 25 to 45% reduction in the snowpack in the spring by 2075. So, and where that varies spatially, we're lucky here in Colorado that we are relatively high elevation, so we're a little bit sheltered from these most immediate impacts, right? It tends to be a little bit colder here than, say, the Pacific Northwest, where they're already hovering right around that freezing point, and so you warm by 2 degrees, and that's really bad news. That means a lot more of those events are going to come in as rain, and that's where we're going to see the most acute impacts of like a 45% reduction in the amount of snow water equivalent in the snowpack.
Dan, sorry, you sort of touched on this, but what if, from a ski resort perspective, I know blown snow is not ideal, but it's something.
Yeah.
But it can be done easier when it's colder, right? So how are they expecting the temperature at where our current ski resorts are to change? Like, how many opportunities are there going to be to adapt?
I might turn this over to Allie really quickly here, but who remembers December here at Fort Collins? you walk around in a t-shirt a lot of days. What was it, like 3 degrees Fahrenheit above average? Like it was just incredibly warm the entire month. The ski resorts felt that as well. I mean, I was watching Winter Park where I ski a lot, and like they were not able to make snow for a lot of the month. They had like one of the slowest starts because of that. And so, yeah, I don't know how you're familiar with the future projections and what that warming looks like, but not going to be a good situation.
Yeah, I mean, I think a lot of us in this room know that our temperatures are expected generally to rise in the coming century. But I guess one thing that I'll add is that doesn't mean that we won't continue to also see the occasional cold snap and also see the occasional big snow year as well. Our precipitation expectations for the coming century are less clear than they are for temperatures. Temperatures we feel very confident in that those will increase over the next century. Precipitation is a bit murkier. And it's also, you can get very localized effects in particular areas, especially places like the mountains where the orography can kind of enhance snowfall. So I guess all that to say, like, yes, we can expect more warm years, more dry years, but not to say that we won't also see those big boom snowfall years also.
Okay, question back here.
Hi, my name is Pat. I have a few questions, but I'll just ask one for now. You're all working on research projects, and I'm kind of curious to know, given our current assault on climate science, and not only climate science, but climate funding, and even beyond that, even some climate data, I'm curious to know if your projects specifically have been affected, or at least today, or at least projects you had planned, because you're clearly looking at long-term issues related to climate, and I'm kind of curious to know how that's affecting not only your livelihood, but the quality and quantity of the research you can accomplish.
I'll start with my project is not actually externally funded, so not affected directly right now.
Yeah, I think, we're the Colorado Climate Center. We're pretty forefront of the things that we do. But I think so far we've been pretty fortunate to not be seeing at least direct impacts on our funding sources from the federal government. A lot of what we do is drought related. So that's pertinent to a lot of folks in agriculture, which, tend to be more on the side of the current administration. But I will say, I think that the biggest impacts that we've seen is the changes in the workforce that has worked for the federal government. We've lost a lot of folks that our office has worked with for decades, that we've built really strong relationships with in places like NOAA and the USDA. And some of those roles haven't been filled again. So for example, we run the weather station on the Fort Collins campus, and the National Weather Service office in Boulder has a person who's responsible for managing all of what we call these cooperative weather stations, where you have human observers kind of managing the station and taking observations. That role has not been filled again. We've actually been working with the person in the Pueblo forecast office since Boulder currently does not have somebody in that position. So I think that that's kind of what the hardest part has been for us, is sort of losing those long-term partnerships and not really having a great way to rebuild them, at least in the immediate term.
Dan.
Yeah, I'll just emphasize that point about personnel. I was in Salt Lake City a couple weeks ago for Bureau Reclamation project meeting, and there were a number of employees from the USDA, NRCS, so basically the organization that runs the snowtel. And he was, one in particular, was describing just how gutted their workforce is. They are just barely limping along with a couple employees of what would have been 5 or 7 or 9 on this team. And just, the whole meeting was focused on snow water resources in the Western US. There are a lot of reservoir operators, river forecasters there. And that comment was kind of echoed by others in this discussion, that their offices in NWS, or the Colorado River Basin River Forecasting Center, it's one of the longest acronyms ever, they were just at a small percent of the number of personnel that they normally would have. And so I think that's really where there's a really immediate impact being felt.
Question back here, Joe.
Hi, I'm Jill. This is a question for Jed. If our snow drought persists, what do you think happens to summer recreation?
Yeah, that's a great question. You can think about the water dependence on a lot of summer recreation activities. So reservoir levels, river activities, fishing can have ecological consequences, that can affect other factors. So it can certainly cascade down into summer. And if it affects, if droughts continue and we end up having warm, especially windy, dry spells, that can lead to more extreme fire seasons, which we're starting to document a lot of impacts on recreation. So I think there are lots of possible channels. We'll have to see how the season ends up, right? Ends up playing out. But you can imagine lots of potential impacts.
Allie, I have a question for you. It seems, when we start talking about, we're having a very broad conversation about snow and precipitation in general, but the conversation about snow, how do you communicate to people in Eastern Colorado that this is going to affect them? I mean, how do you make the calculation from snow depth? How does it get to the flow gauge? I mean, do you guys have models for that, or how do you have monitoring that goes from snowpack to gauge to reservoir? How do you do this? Is it just based on the snowpack or some other way?
Yeah, in our office, we don't have any sort of in-house models that are tracking the movement of snow to, down the riverways upon melt. That's really something that I believe the NOAA River Forecast Centers, they kind of deal with those sort of seasonal stream flow forecasts. So we're not, we don't make those sort of predictions directly. We have been looking at some of those forecasts and they're obviously not great, as you might expect. Snowpack and stream flow are very closely connected. Does that sort of answer your question?
Okay, good questions coming over here.
This one might also be for Allie. My name's Maggie. Just wondering if you can talk a little bit about any projects there might be out there that are really centering communities, those that might be most impacted by these issues we're talking about, attempting to sort of co-create solutions to increase their resiliency.
In terms of solutions, nothing is coming to the forefront of my mind, but I would be remiss if I didn't mention this citizen science project that our office does, which is the COCO-ROS program, the Community Collaborative Rain, Hail, and Snow Network. It was started right here in Fort Collins. It's now a national network that also is in parts of Canada. It's backyard rainfall measurements, and that rainfall data is actually the largest precipitation data set that the NOAA and the National Weather Service uses. So this program started in 1997 during the Fort Collins flood. We're kind of getting towards 20-year plus records for some of our earliest observers that started. So we're starting to kind of get like these localized climate records from these observers that have been measuring daily precipitation in their backyards. That information is not only useful for looking at the historical records, but I think it can also sort of inform the research that we have about precipitation and that sort of thing. Not directly related to sort of snowpack and climate change solutions, but it's a really robust precipitation data set that we don't really have another example of. So that's what comes to mind first. Sorry, it doesn't totally answer your question, but yeah.
Okay, question here.
Dave, are we expecting more hail? And if so, why? And what are the consequences of that?
Yeah, hail is a really complicated question because the observations that we have of hail are mostly where people are. So we're missing a lot of data in these more rural areas. So kind of knowing what we have about the past, the historical data set, we kind of use that information towards making future hail projections. It's a complicated question. With a warming climate, we expect the atmosphere to generally be warmer. So kind of the general consensus that I've seen is that we expect there to be fewer of these kind of small hail events, because with a warmer atmosphere, we'll expect a lot of that small hail to melt before it reaches the ground. But there is some indications that these large hail events might increase under future warming. I'm not sure if off the top of my head I could speak directly to why in the atmosphere that particularly is, but yeah, sort of the general trend that science has found so far is big hail event, increase in big hail events, decrease in smaller hail events.
Okay, question over here.
My name's Cassie. I'm in the watershed science department at CSU. I know this is gonna be a little bit more specific for Dan, but I know you said specifically you've been doing a lot of research with glaciers and snow up in Alaska and Patagonia. And there's been a lot of glacial flooding in those areas as well. So I was just wondering if there was like any specific mitigation strategies that you guys were looking towards and like doing research on to kind of help those communities in those areas and like the effects that they're having with the flooding.
Yeah, great question. The primary source of that flooding, which was referred to as glacial lake outburst flood, so QLAFs for short. And we are seeing an increase in the number and area of glacial lakes around the world, right? Glaciers are losing mass I'll throw some numbers at you and I'll try to do a conversion to make some sense. They're losing mass at 273 gigatons per year. 273 gigatons, no one has any idea what that means. I don't even know what that means. But a gigaton is 1 cubic kilometer, the mass of 1 cubic kilometer of water. So imagine a kilometer by a kilometer by a kilometer, big box, big cube. Fill that with water. That weighs 1 gigaton. And so glaciers globally are losing around 273 gigatons of ice annually. As those glaciers lose mass, they retreat and they thin. It leaves behind these basins that accumulate water. And so that's why we're seeing this increase in glacial lakes throughout the world. These lakes come in many different kind of varieties. Some are dammed by moraines, which is kind of the rubble in front of the glacier. Some of them are dammed by ice, and they have different kind of outburst flood characteristics. The one that's been in the news the most recently here, at least in the US, is Suicide Basin and Mendenhall Glacier outside of Juneau. And I don't know if you heard the news, but the Army Corps of Engineers considering, and I think strongly considering, anywhere from a $600 million to $1 billion project where they're going to bore a tunnel over 6 years to this lake basin and establish a stable drainage to minimize the flooding risk from Jude. I don't think they consult a lot of glaciologists because there are 27,000 glaciers in Alaska and there's way more glacial lakes than that. And you set a precedent where our approach to dealing with a glacial lake hazard is we're going to bore a tunnel that costs $1 billion. Not the road I'd want to be heading down myself personally. So what can you do mitigation wise? Really a lot of high mountain Asia and the Andes are at the forefront of this, where that risk is much more apparent to them, right? There's entire communities right beneath a big glacial lake. And they have lower cost ways of dealing with that, where they'll kind of establish a concrete pour over or stable drainage there. Some communities have even turned that into a hydropower source, which is awesome. So there are approaches. Probably the best first cut approach is an early warning system. So you install a sensor in that lake and identify when that stage is lowering rapidly to give some early warning to downstream communities to get out of the way of that outburst flood. But glaciers are losing a lot of mass. They're going to continue to, projections out through 2100 are for increasing rates of mass loss. So we're going to see more of these lakes and likely an increase in the frequency of these drainage events. So it's a problem we're going to be facing for a while.
From a snowpack standpoint, what is the value or importance of snow that forms at a high elevation but doesn't stay at that high elevation and actually blows down to a lower elevation? Is there an importance from a snowpack standpoint? I guess my question revolves around if we agree that there's a warming of the climate and we know that snow consolidates at a higher elevation because it's colder, what is there an importance, or is there a study or research on snow that blows down
and consolidates?
I think a bigger concern related is like blowing snow and movement of snow is sublimation, where that snow goes from the solid phase to the vapor phase. And something like 30% of our snowpack sublimates, right? If you've been up to the higher elevations in Colorado, right, a lot of snow accumulates in the coniferous forest, like on the trees. And a lot of that snow sublimates back to the atmosphere. So anytime you have like literally a particle of snow or a grain of snow in the air, some of that's going to sublimate away. And so I think that could be a bigger part of that we should be studying.
Question. Oh, our director, here we go.
Hi, everyone. My name's Courtney. Thank you all for being here. My question's for Jude. I'm wondering if you could talk a little bit more about some of the social and economic impacts we're seeing from this drought, and also things that communities are maybe doing to prepare for that, like anticipating that this is going to become more common.
Good question. Okay. So, I mean, in terms of impacts, I think we're starting to see the, reports on, reduced economic activity. That Vail resorts reported their visitations like down 20%, across their resorts, things like that. I think interestingly enough, their revenue that they attribute to lift ticket sales is actually not down that much because they've convinced us all to get the passes, but what they're seeing really big decreases in is like dining and ski school and stuff like that. So it's the other things, and that's cascading into workers and then into those communities where those people work and live and spend money. And so I think we're gonna start, economic data has always lagged. So we're gonna start seeing some actual numbers on how that's affecting those communities. And I think that question earlier maybe got at how some communities are trying to deal with it, in the sense that they're trying to find creative ways to bring people to those areas. There is, this is only sort of tangentially related, but your comment reminded me, there's an economics paper that I really like that is about how people respond to snow depth in terms of visiting ski resorts. And economists like to talk about elasticities, which is basically how a percent change in something affects a percent change in something else. And one of their notable results were Colorado actually is the least sensitive to snow depth changes from a skier perspective. And I think it's largely because people, know Colorado. It's historically been consistent, good ski destination. And so people make their plans to come here and they're going to come here. Now, if we get many of these or these sort of headline bad years, those things might start to change. But historically, our ski industry, sort of snow sport industry more broadly is sort of less vulnerable than even say Utah or California, where when they have bad snow, their visitation really falls off. So I think that's working in our favor for at least the near term. Long term, I think it's trying to find ways to diversify the offerings, the communities trying to find, we're already seeing a lot of like more shoulder season activities, summer activities. These communities are trying to hold events, attract people to these areas. I think that's probably what they're thinking long term.
Okay, question.
Behind you.
Yeah, okay, good.
Go right behind you.
Oh, I'm sorry. Thank you. Didn't I just say hi? I haven't had a beverage all night.
I'm Mary Geisinger. I'm a government consultant and environmental planner. So this is kind of the question in regards to the utilization of the data that's been collected in this kind of year, as well as, in previous years when a similar kind of weather pattern has occurred in Alaska as well. What kind of predictive modeling is being developed or explored in regards to looking at the effects of this kind of snowpack on water recharge in the environment as a whole? And is any of it being applied towards government planning and economic planning for the future?
a stab at that from the snow perspective, at least, and how that turns into, water in a river. I referenced that meeting in Salt Lake City, and it was one of the first times in my career I've had the opportunity to really sit down with a lot of like river forecasters and reservoir operators. And I learned more in the day and a half I was there than I often do in a week-long meeting. And right, there's a really, really wide range in approaches. There's folks that have been doing, they've been operating some reservoir for 40 years, and they operate off intuition. Like, that's it, right? They might look at, it might go up to one spot and probe the snow depth, and they have their data point of n equals 1, and they're like, this year I'm going to do this. To the other end of the spectrum, where there are, there are entire departments, at NWS that are running really sophisticated, physically based snow models. And those snow models are incorporating airborne LiDAR data. So there's the Airborne Snow Observatories, which is a private company. We're doing a lot of airborne LiDAR flights here in Colorado. The state government has brought together a lot of partnerships between different municipalities. It's CASA, it's the Colorado Airborne Snow Monitoring Program. And so these, at the kind of the most sophisticated level, they're pulling in these airborne LiDAR data sets to kind of correct their model and, incorporating that into the physics-based model. So there's a really wide range from, single n equals 1 to kind of the most sophisticated snow modeling you could possibly do with these airborne observations.
Do you guys see anything, is there any shift like, with the cutback in the government, the private sector getting interested in water and monitoring water? I mean, it seems to me, if it's this limiting resource, we're not measuring it enough. Or do you think we're measuring it enough? Like, so how would you, if you were king of the world for a day, so how would you fix that? How would you do a better job of that? And I'm not putting it on you. You do good work, but I'm just saying, how would you do it? What kind of data do you need?
It is gone private. This Airborne Snow Observatory started at the NASA Jet Propulsion Laboratory, and after a few years in an incubator program there, they launched into a private company. And so I don't know what their numbers are, but I'm guessing it's in the tens of millions of dollars to $100 million in investment per year. I'm literally just pulling that number out, but what they're flying, right? They'll fly multiple basins all along the Sierra Nevada, here in Colorado, basins in Idaho, and that gives them the most spatially complete picture of what's happening, right? What I was referencing before, right? These snowtel sites, there's only 115 of them in Colorado, right? And snow depth varies tremendously over really.
And they're all above 8,000 feet, right?
All really high in elevation and a relatively narrow elevation range.
Yeah.
So if you go out and probe the snow depth next to the snowtel site and then walk 30 feet away and probe that and then walk another 30 feet away, you're going to get a different answer at each one of those spots. Right. And so having this ability to map the snow depth across the entire basin provides a really unique perspective that's really valuable.
Questions? I hear you. Your name?
Hey, I'm Cy. So I think we kind of established that due to climate warming, at least in the Pacific Northwest, snow events are turning into precipitation events. What's that about? Like, what are the consequences of that, or the implications on like reservoir levels? And I gotta imagine Portland takes a hit, right?
Yeah, that's a good question. So, we kind of saw one of these events in Colorado this year, which is a rain on snow event. You might have seen some headlines around Christmas time. There were a few base areas of some of the ski resorts in the mountains that were seeing precipitation in the form of rain rather than snow. So yeah, these rain on snow events can lead to flooding issues. So I think that's perhaps one thing to think about with, these greater opportunities for rainfall versus snowfall. Yeah, I don't know. That's something that
Yeah, I think one of the most critical impacts is just that loss of this natural storage term, right? This natural reservoir. If you had to estimate the value of that, I'll ask my economist friend over here to do that. Right? It's a really, really big number, because if you think about how much snow is being stored over this much area, if you had to maintain that in a human-made reservoir and operate that reservoir, we're talking, I don't even know, billions of dollars to do that. And so we have this incredible natural reservoir that we've built our kind of entire society here in the Western US on. And in areas where that's most acutely being impacted, I think we're gonna see that impact, that we just don't have that water available when we want it. And I hate to be the bearer of bad news. I was looking over some of my notes. Been bearer of bad news on a lot of fronts here. I referenced 2075, right? Is when we're gonna see these declines. 2050. So west-wide by 2050, we'll see a 25% reduction in snow water equivalent in the snowpack, and 45% in the Pacific Northwest. So 25 years earlier than I misspoke before.
One question over here.
Hey, so if price reflects scarcity, and if water is becoming increasingly more scarce, why is water like the most inexpensive utility? And then are we going to all of a sudden see just a giant spike in utility bills for water once we catch up to the numbers that you just said, Dan?
Very good. She's picking on me. So what's happening? Yeah, so I think it was a leading question because we do not price water based on scarcity, right? It's certainly not the water that we consume as residential consumers. I'm actually probably the wrong economist in my department to be up here talking about water pricing. But long term, things will probably need to change. So when resources do become scarce, we do need to find ways to ration them. Water is a particularly sensitive one because it's so important. And, economists do tend to like the prices as a rationing mechanism, but that has equity issues too. So, I think long term, the West is going to have to confront these issues. As Dan mentioned, these projections about lower water availability. It's going to probably be, challenging negotiations early on, and then get to the point where we're going to need to start thinking about who bears the cost of that. So, you can think about, how we have historically augmented our storage capacity is by building reservoirs, right? And we're talking about doing it around here too, and those are expensive, right? And they're not only expensive in actual financial terms, but in the opportunity cost of what we do with that land and in the absence of filling it with water. So I think those will be the long run issues and big challenges that we have to deal with. So good question.
Question back here.
5 extra points.
Thank you. I don't know if this is a good question or not, but I'll throw it out at you. Whoever wants to answer is welcome. I'm concerned about something that, I don't know if it can be measured or not, but the health of our forests is under threat, all right? Through beetles and drying and fires and all of that. It would seem to me that would have some bearing on the snow aspect of what's happening with melting and how those trees that are so unhealthy are gone now. I've heard reference to, the melting of it in terms of the soot and everything that was from those fires. But what about on an ongoing basis as we go into more and more wildfires and things, and we're reducing the number of trees that cover these areas that we're storing snow? Does that matter that much or not so much? I'm not sure.
Yes. Yeah, absolutely. I mean, I think that's a great question, a great point, right? The forest health across the Western US is not great, right? If you look out and see the amount of beetle kill that's happened here in the last 4 decades, like it's increasingly prevalent across vast swaths of the Western US. There is, there are connections between the snowpack and fires the next summer, right? So if the snowpack melts earlier in the spring, you have a longer dry season where that soil and the vegetation can dry out, and you may see increased fire activity that following year. And as when we stack these years, in certain locations, year after year of low snow, then that forest health is going to be impacted. The vegetation is very stressed given the current state of moisture and warming. And so I think that does have a really big impact on forest health and subsequently on the snowpack, where the loss of vegetation is going to increase the amount of radiation that reaches the snow surface. There have actually been a lot of studies that have been done, I think funded by logging companies. I've never really dug into like the funding sources of some of these studies to find the optimal thinning pattern of a forest to maximize your snow water yield, right? You can think about this kind of scenario where if you have really dense forest, you're going to have a lot of that snow that's caught up in the canopy and it sublimates away. It's not actually being added to the snowpack. But the snow that does make it to the ground is going to be shaded and is going to persist much longer than it would in the open. At the other end, in the totally wide open, no vegetation, right? All that snow is going to reach the snowpack surface, but it's exposed to the radiation. So there is this kind of optimal thinning pattern that loggers, I think, try to take advantage of, where they're going to manage their forest for maximum snow water yield. And that would be kind of in between this canopy conditions where you get the benefit of both. I'm not sure that really answers your question.
Okay.
Yeah, I'll tack on to that, because I think you brought up a couple of really interesting issues. That the fire activity, you know, and historically we've suppressed fires pretty aggressively, and so the health state of the forest has already been altered, and in some respects maybe there is too much vegetation on in a lot of areas, and so I mentioned maybe in my intro that my other hat is fire. I work in a lot of fire management issues, and I'm certainly not the expert in the fire ecology, but from what I gather from my colleagues, I think there's a desire to have more fire on the landscape, meaning more sort of recurrent, not the super intense, stand clearing fires, but fires that thin out a lot of vegetation and actually let trees grow in that sort of spacing that maybe we might desire. And so I think there's these stressors are affecting, all seasons, the forest from sort of all dimensions. So if we have these highly variable snow seasons, that's stressful to the trees. Also maybe more extreme fire conditions, also stressful. While also we as, stewards of our forest want to balance, good healthy fire too. And so it's complicated, right, in that area. So thanks.
Lee McDonald, I'm a forest hydrologist, and if you're really bored, I wrote a book called Forest and Water, State of Knowledge for Colorado. It was published in 2003, but forest hydrology hasn't changed really that much. And trees are really big straws. They're pumping water out of the soil big time all year round, especially during the summer. And so you have to look at the forest effects, not just from the winter snowpack accumulation, which we're talking about here, but also what happens in summer. And so, yeah, if you clear cut a forest, you get way more water. But if you only take out a few of the trees, the existing trees generally take out a lot of that extra water, because forests are generally water limited in Colorado. So I'm just saying, you got to look at the summer and the winter aspects and how they add up over time.
Hi, I'm Mick. I have a real simple question. How do we capture the cost to assets, evaluate them, and then apply them to public policy?
Real simple question.
He's a CSU guy, I bet.
So let me make sure I'm getting that right. Capture the value of assets. So the value to society of the services that our forests and water and natural resources provide.
Beavers.
And beavers, yeah. It's a challenge. I'd say that there's a whole area of natural resource economics that is focused on that. We have some. I'll say we're good at it in some areas and less good at it in others. So for ecosystem services, what we generally call them, or natural capital, we're pretty good with things that eventually enter the marketplace. We have ways and, economic frameworks for measuring that and putting values on things. Now for more complex processes, like how some, forest or water system supports other indirect things that affect our lives, we're not great at valuing that. I think the positive spin I'll put on it is we know conceptually what we want to do, but empirically it's very hard to do because the values are really a result of how we feel about things, how we behave, what resources we're willing to devote to things. But I think you hit on exactly why it's important, right? Because if we don't measure these things, and this is the argument that economists have tended to make, if we don't measure these things, they don't show up in public policy, right? If they're not, we account for bridges and roads and, all our forms of financial capital. And if we don't have the environment to put on those balance sheets, then we don't see, from the policy perspective, we don't see the damages or the degradation. So we and natural resource economists argue that it's important to value these things, or at least attempt to put them on equal footing, so that we are designing a policy that's recognizing that we want to preserve these values. And we all know we value it, but putting the actual dollar amount to it, well, we're better in some ways and not in others. I will say that's maybe to the political side that we hit on earlier.
We're going to go to that now. So
okay.
Yeah.
Okay, so we can transition. That was one of the big disappointing things. The federal government had the Bureau of Economic Analysis, Bureau of Labor Statistics, and the Office of Science and Technology and Policy in the White House had really laid down the foundation over the last 5 or so years to really make some important steps forward in natural capital valuation. And my hope is that's just on pause. It's certainly not active at this moment, but I don't think that institutional knowledge has been lost quite yet. So I'm hopeful that when things change, we can resume some of that.
Is that going to help us in Colorado? I mean, what are we doing wrong? Right? We have this problem, wicked problem. Where we start. So what if you were not take off your profession? We're just like, what are we doing wrong? Like, why do we have such issues around water? Like, who can we blame? Who can we point our finger at? But what do you think it is fundamentally? Is it we don't know how much there is? We don't know. What do you think is what's the outside of a warming planet and a real change in weather patterns? What are we doing wrong with water? Like, is it just that from the very beginning we were wrong in the way we took half the water from Colorado River and brought it over the Front Range, or so just like, what do you think? What are we doing wrong? I'm not doing anything wrong. I know you guys are. So
I'll comment on the snow side.
Yeah. I mean, what are we doing wrong?
There
Yeah.
is a lack of the ability to observe how much snow is there.
Okay.
We have not invested in appropriate means of measuring the spatial patterns in snow. 850 stations is far from enough to truly know what the state of the snowpack is across the West.
Right.
And we had a little discussion, we were just chatting before the panel started, and I referenced, there was a 2017 paper that tried to put a monetary value on snow in the Western US. What's the audience think? What do you think that number was? Trillions. Yeah, trillions of dollars. Right? You know how much money we've spent on snow monitoring? Like a couple $100 million, maybe,
Right.
probably something like that.
Right.
A very small fraction of what the value of this resource is. And from my perspective, really, we need to know how much is there, because the historical baselines are no way to guide how we should be making decisions in the future. Years like this, where you have steeper gradients than we've ever seen before, snow-free in the valley bottoms, 4th deepest snowpack at the highest elevations in certain locations. Like, we don't have the ability to measure that, and so there's no way to effectively manage it from my perspective.
Okay, Allie, what are we doing wrong in climate monitoring? I won't blame Russ or you. Just tell me what you think.
I mean, we can always use more weather stations.
Yeah. Okay.
Yeah, I don't know. I kind of similar to what Dan discussed earlier. I wonder how, like, how limited our snow observations are and how we are like missing things in our modeling for forecasting runoff and snowpack predictions. I don't know. Yeah, I guess I'm thinking of it as yeah, from a monitoring perspective. I was also in my brain kind of going off on a tangent towards like, I think just as humans, we are used to the way things are and like we don't want to give up what we've been used to. And I think that that's a lot of what happens with is happening with the Colorado River Compact. We're used to like the allocations that we've had. And yeah, I don't know, I'm not a philosopher or anything, but this is just like the things I think about sometimes.
So now, Judd, tell me how confident you are in doing policy when they're telling us we don't have enough measurements. So give a good up and doing that.
Yeah, well, I think until today, I was maybe a little more confident that we were better at measuring that. But I'll take a shot and you know, at the risk of being like that economist, I think we can price things a little differently, right? We can think more seriously about pricing things according to scarcity and you know that, and we can address some of the negative consequences of that with other policies, right? So if we're worried about equity, there are transfers and rebates and, you know, options like that. But if we are going to get serious about water being a scarce resource, then I think we have to have some system to guide that allocation.
Hi, I have another question. What, if you guys have talked about this individually or just in your departments, like, is there anything specifically that we as a community or we as individuals can do to spread the awareness about all these things? Like, I know people say take shorter showers and like don't leave the water running when you're brushing your teeth, like those kind of things. But is there anything specifically that's talked about that like we can start doing now before it gets really like bad enough to where everybody has to be like doing those changes, if that makes sense?
I think one thing is being here and learning more about the issue, right? That's a huge first step. And if you go talk to 3 people, and every single person in this room talk to 3 people, right? You can just see how quickly that balloons out. The more people that are aware of the issue, they're talking to their neighbors and they're saying, oh, like, right, the snowpack's in the news a lot, but like having those conversations of actually like what we could do about it. So I think educating yourself and then talking with your peers and others is a really valuable approach.
I just totally agree with that. Yeah, I don't know. Sometimes I get disheartened that like my acts as an individual maybe aren't adding up. But yeah, I think that just like awareness piece has a bigger impact than we sometimes think it does.
Question there. Well, I certainly agree with Jude about pricing. I think we, as Americans, pay too little for food, and a big part of food is water. And so we really don't price water appropriately. Agriculture gets an extraordinary amount of our water. I mean, we can take shorter showers and do those things, but agriculture uses the bulk of our water. But my question really is Dan, specifically, if you had more monitoring of the snow, what would that do to, what decisions would you make differently if you just knew more about the snowpack? Because I can't kind of make that step myself to go, well, you're not changing the amount of snow that's there. It's still going to run off. It's still going to be stored in reservoirs. So if you had more monitoring stations, how would that impact decisions that we would make policy-wise?
Specifically about reservoir operations, where the biggest impact would be, right? If you're operating a basin in the Sierra Nevada and you're trying to make decisions in March about should you let these flows pass through the reservoir, should you start storing them? Right now, you're blind. You might have 2 stations up there, and perhaps, you know, one's down low where there's no snow and one's up high where maybe there's a lot of snow. So you start making these decisions, these like arguably $1 million decisions with not a complete picture of what's actually happening. And so maybe you make a decision to hold on to those flows. March comes in, April comes in, they're really wet months, and all of a sudden your snowpack is 3 times what it was when you made that decision back in February. And now you can't get that water out of your basin fast enough, and you just flood it downstream because you weren't able to make those measurements. So it's a combination of being able to monitor in real time and have more accurate weather forecasts for what the next 7 to 14 days are going to be. What's the next 30-day period going to look like in terms of the moisture we're expecting? That information is absolutely critical to making informed decisions. In the absence, we're just turning knobs and not really know what we're doing.
Hi, my name is Pamela Murphy and I'm a retired teacher. And, you talked about spreading information. And then Allie, I think you mentioned earlier about outreach. So I tend to be a one-trick pony, wondering what we're doing, even if anything K through 12, to get information out there. And at this point, with all the changes going on, what message are we delivering to our youth about their future and what they can do, whether it's job opportunities, careers, and the like?
Yeah, I was just actually today at a school down in Erie talking about precipitation and snowfall. So, yeah, I just feel like, I don't know, it's part of our obligation as scientists to like be out there and be sharing our work, not just being in our little bubble of what we're doing. Yeah, so it's a difficult question. I mean, in my job, I'm trying to kind of bolster our resources that we have and kind of, make resources available on our website that we can point students to. We actually, in our office, get quite a few requests from students directly saying that they're doing a project on climate or something, and they reach out to us and want to talk to a weather expert, which is fantastic. So I think that there's already at least some of that going on, which is really great. Yeah, I just feel like those conversations just really help things take off. But yeah, I don't know, tough question. But I try to say yes to as many things as I can to get out there in the community and talk to people. Just, even if it changes one person's mind, I feel like that's a job well done.
Hi, Evelyn Clark, CSU Larimer County Extension Master Gardener. You asked what can we do, and certainly showers and being vigilant of water use is one thing, but a really big deal is your landscaping. Go with Xeric if you can, and really take a look at the water use. I have a feeling we're going to have some rationing and this summer, and if your plants are low water needs, it makes a massive difference on what we're using here.
Okay, one more question, anybody? Okay, all right, we're almost up to time. You guys are just great tonight. You really knocked it out of the park. Let's give them a round. Oh, wait, you want to? Wait, he's got, well, here's the last question.
It may not really be a question, but we're all talking about the transformation of snowpack to stream flow. And you talked about the uncertainty in snowpack measurements, but the uncertainty in terms of how much moisture is in the soil and what the transformation efficiency is from snowpack to stream flow. And, Nolan Duskin said we need more soil moisture measurements. And then with a warming climate, we also have greater evaporative use in the summer and drier soils potentially in the fall and winter. And so we're going to have less efficient transformation. I don't know if you have any numbers or suggestions on how much the transformation efficiency is changing with changing climate.
That probably is a good
Well,
question.
I don't want to do it. No, so we received money from Bennett Hickenlooper to actually instrument soils all over the state of Colorado.
Right.
So how many stations we have now in addition to all the four? No, that's the new ones, but we had like over 400 sites that we're re-instrumenting. So, but still not enough. Like I could argue the same thing. It's, it's so variable, and we're relying on things like AI, for forecasting and remote sensing. So we have to use everything in our power to make this work. Let's give them a round of applause. Great job tonight. And we have the room for about 4 more minutes. So if you want to ask them some questions, come on up.